Hi, I'm Amit Parija from Whiteley. In this presentation, we are going to cover how to do ETL using Hadoop. Over the last few years, organizations have made a strategic decision to turn big data into a competitive advantage. The challenge of extracting value from big data is similar in many ways to the age-old problem of distilling business intelligence from transactional data. At the heart of this challenge is the process used to extract data from multiple sources, transform it into fit your analytical needs, and load it into a data warehouse for subsequent analysis. A process well known as extract, transform and load, namely ETL. Okay, this is how a traditional architecture of ETL looks like in most organizations. First comes the source layer, which consists of the structured data only. Very complex when it comes to loosely structured data. Then comes the data collection and processing layer, where we are compelled to discard a lot of data due to high cost or performance issue. The third comes integration, storage and business presentation layer. A lot of time here is spent on understanding source and defining destination data structures. Enterprise data warehouse is used then with lots of transient staging tables and loaded onto business specific data marts. In contrast, this is how a Hadoop ETL platform looks like. The source layer consists of any format of data. This could have structured, semi-structured or unstructured data. This is then loaded real-time into Hadoop platform, which provides a massively parallel and scalable storage. This stores and transforms raw data on commodity hardware, so the cost is pretty less. It is then loaded onto an enterprise data warehouse, but the difference here is you can now keep the recent data only and focus more on analytics. This is how the ETL blocks or the architecture looks like. On the top you can see sources of data, which could be social streams, weblogs, data logs, databases or RDBMS, and blob data stores. The extract block consists of tools like WebHDFS, Flume and Scoop. These are basically tools which are used to extract data from the sources and load it into Hadoop. Then comes the Hadoop ecosystem, which consists of primarily the Hadoop distributed file system. Then comes Pig, which is a platform for analyzing large data sets that consists of a high-level language for expressing data analysis programs in a highly parallel medium. Then you have HBase, by and large the most popular column store database or a NoSQL database. Over here you can also use any other NoSQL database that suits you. Then you have Hive, which is used as a querying language or as a data warehouse. Hive consists of HiveQL, which is the Hive query language. Then comes the load part, which consists of the connectors, which helps you connect to visualize the environment, which consists of the data warehouse or querying and reporting tools, or to do the further analysis from there on. Now we'll show you a live demo on how to do ETL for two kinds of data sources, one being the weblogs, where we have programmed Flume, and two being RDBMS, where we have programmed Scoop. The platform that we will be using is Intel distribution for Apache Hadoop. Now there are various reasons why we are using Intel distribution of Apache Hadoop. It is built from the silicon up for performance and security, which means running the Intel distribution on Intel processors enables Hadoop to fully utilize the performance and security features available in the x86 instruction set in general and the Intel Xeon processor in particular. Automated performance tuning. This integrates mechanism saves time while delivering a more optimized configuration. The Intel distribution includes a management console that provides an intelligent mechanism for configuring the Hadoop cluster, so it is then pretty easy to manage the whole cluster. Support for a wide range of analytical applications. These applications come from the leaders in the field, most of whom are already collaborating for ETL at a hardware layer like SAP and SAS.
Hi, in this screencast we'll show you an ETL demo of a sample log file using Flume and Hadoop. To begin with, this is the structure of our log file which we'll be using. It has a date time, an IP address, a country code, and an error and a success code. We'll be using Flume as a transport tool for transporting the weblogs from the server into the Hadoop ecosystem. Flume consists of a configuration file where we define the sources and the sinks. The source can be defined in this particular manner where we are actually using a shell command to read the final lines of a log file. We also configure the sink which defines the place and the path where the log file will be written into Hadoop. Once we have configured the configuration file, we can start the Flume agent using the following command. So now you can see that the Flume agent has been started and it will be continuously listening to any log files which are generated in real time. So once we have started our agent, the next step is to define a metadata schema to store our weblog data. For that, we use a Hive table to create to store the data from the log file. As you can see that the Hive table has been defined in a way that the first part of it is time, IP address, country and status as defined in the log file. So this we have created a Hive table which actually points to the data in our Hadoop ecosystem. Next we generate some sample logs files to be analyzed. So you can see out here that Flume is writing the log file into the Hadoop ecosystem. Now it's done. We can check the log files created into Hadoop by doing a simple LSR. So now we can see the log files generated out here and written into the Hadoop ecosystem. Next step is to visualize the data which we have written into Hadoop. We can use multiple visualization tools like Excel, Tableau, and there are many other free as well as paid versions of analysis tools. Out here, we are using Tableau to visualize our data. Using Tableau, you can easily connect to the Hadoop data and visualize it. So, here you can see how the error logs have been generated out here, showing us the points or the IP addresses where we got an error connection. We can further drill down into the data using the data sheet in Tableau. and check out the IP addresses from which we got an error status. Now you can analyze the IP addresses from which you are getting a maximum number of error status and then block those IP addresses, as those will be the malicious IP addresses. That will be all for this demo. Start. Hi, in this demo we'll show you an ETL process using Scoop. Scoop is a tool designed for efficiently transferring bulk data between Hadoop and structured data sources such as relational databases. Let us first check the table which we'll be using to transfer into Hadoop. The name of the table is called persons and it has 3 rows inside it. Note that in actual real world scenario we'll be having thousands and thousands of rows. Next we use the scoop import command. With the scoop import command we can bulk load the data into Hadoop. In this command we mention the connection string to our relational data, the table name and sub-user authentication arguments. By default, Scoop exports the data into HDFS. Here we could see the data is getting transferred using an inbuilt MapReduce job, so the transfer process completely utilizes the power of Hadoop. Let us now check the data which has been exported into HDFS. As you can see, there are 3 records which have been formed corresponding to the 3 rows of RDBMS. We can also do a cat command to check the values inside the file. We can directly transfer the data into a Hive data store with the same schema, or if required, different schema. Storing data into Hive gives a defined schema for our imported data. Since Hive uses HDFS, we need to first clear the data in HDFS. Now we run the same command as we ran earlier with an extra argument called Hive import. By adding an extra argument, we can directly store the data into the Hive metadata store. Let us now check the values in Hive. As you can see, we have bulk loaded our MySQL data into Hadoop.